Hi. So you guys already know how to factor stuff that looks like this, right? I have x squared plus 6x plus 9. You're really good at factoring stuff like that. But today, I'm going to tell you what to do when you have something out front. You might have a 2. Or these might be different. You might have x to the third, x squared, and an x right here, okay? Today, I'm going to teach you how to factor completely. And whenever you see factor completely in the directions, right, that's telling you that you need to look for a GCF. So remember, GCF is the greatest common factor. Okay. And the greatest common factor is going to be the largest number that you can divide each term in the polynomial by, and it's an even nice number. Okay. So in number one, it says you're going to factor completely. So the thing that I usually do when I'm trying to solve these, right, is I just like look at the leading coefficient and I try to see if that's going to be a number that I could divide each term in the polynomial by. That's usually a nice trick. So I'm going to take that 2 and I'm going to divide the first term by 2. I'm going to divide the second term by 2 and I'm going to divide the third term by 2. And I'm going to see if 2 is in fact the GCF. Could it be 2? Ooh, I don't know. All right, so 2x squared divided by 2. These will cancel, and you'll be left with x squared. Negative 10x divided by 2 is going to give me a negative 5x. And then 12 divided by 2 is going to give me a 6. The GCF goes on the outside, all in parentheses. And yeah, everything divided nicely. So I have factored out a GCF of 2. And then if you'll notice, once I took that out, right, ooh, now I have a nice little polynomial with a leading coefficient of 1. And I know how to factor something like that. I'm very good at that by this stage in the game. So I am going to set up my little box. And this polynomial goes in the box. Do these add up to negative 5? They do, in fact. So I now take these are my two factors, and I have 2 times x minus 3 times x minus 2, and I have factored completely. I pulled out a GCF of 2. So factor completely means pull out a GCF. Remember that. So what happens if you forget to factor out the GCF first? Nothing. It's just more complicated. So that's why you always want to look at the leading coefficient and see if you can divide every term by that leading coefficient. If you can't, or if you forget, you're going to have a kind of a tricky situation on your hands, right? You're going to be putting a 2x squared into the box, a 12 in here. You're going to know that 2x times x is going to give you a 2x squared. And now you're going to have to kind of think about the factors of 12 that add up to negative 10. And that might be hard to think about because you have this coefficient out front. It would be negative 3. You would get a negative 6x here. You get a negative 4 here, negative 4x. Do these add up to negative 10x? They do. So you would get 2x minus 4 as your first factor, and then you would get x minus 3 as your second factor. You would recognize that you can pull a 2 out of this guy here, and you would end up getting the same answer. It's just way more complicated. Always look and see if you can divide that leading coefficient by each term in the trinomial. So number 2 says factor completely. I see the magic word factor completely. That means I'm looking for the GCF. And just use my trick, right? Let's see if the leading coefficient divides evenly by each term in the polynomial. Let's see. Negative 3x squared divided by negative 3 gives me, I'm so sorry, an x squared. And then 27 divided by negative 3 gives me a negative 9. The GCF that you pulled out of each term goes outside of the parentheses. And yeah, they divided evenly. I'm so happy. However, factoring completely might also require you to look for dots or difference of two squares or perfect square trinomials to further factor, right? So in this case, I have the difference of two perfect squares, x squared and 9. So I have the dots. So I'm going to go ahead and factor that guy where I have negative 3 times x plus 3, x minus 3. And I'm all done. He's factored completely. The way you can check and see if you factored completely correctly is you can graph the original. So that's the typed one, right? Negative 3x squared plus 27, graph him. And then right on top of that, add your factored version. So I've got negative 3 times x plus 3 times x minus 3. And yep, they are the same. They are right on top of each other. They're the same function. I graphed it correctly. I have factored completely. So let's go to number 3. Factor completely, magic word, look for a GCF. So in this case, right, I have x cubed minus 3x squared minus 4x. This guy is not going to have a GCF that's a number because there's no leading coefficient listed here, but he's going to have a GCF that's an x. How could x be the GCF? Well, think about it. How do you make an x cubed? You multiply x times x squared. How do you make a negative 3x squared? You multiply x times a negative 3x. How do you make a negative 4x? You multiply a negative 4 times x. What is the greatest common factor? Is the largest thing that you could divide evenly out of each term? It's an x. So go ahead and put your GCF of x outside the parentheses. Divide each term by x. This looks like a negative here. I'm going to erase it. I was trying to show that it's like no number listed. I'm going to divide each term by x. So I get x cubed divided by x. Well, let's talk about laws of exponents. When I divide like bases, I subtract the exponents and I get x squared minus 3 times 2 minus 1 gives me x. 1 minus 1 gives me 0. So now I have my trinomial inside the parentheses. I go ahead and factor that guy. These do in fact add up to negative 3x. I'm good. I factored that. So I've got x times x minus 4, x plus 1. And that is going to be my completely factored answer. So go ahead and check it on your calculator, right? Let's add a new graph. I'm going to type in the original x cubed minus 3x squared minus, go back, minus 4x. Okay. And then now I'm going to add my factored version, x times x minus 4 times x plus 1. Oh, sometimes it doesn't like when you put you don't put the multiply in. There we go. Yay, they're the same. We're good.